Hello everyone, welcome back to this channel, and today we are back with the very important concept, and obviously that is sample papers, previous year papers for ICSE students. And I want you to share this video to all those friends who are in ICSE and even state and CPSE board. So I'll be posting everything for all the boards related to chemistry concepts. It can be a notes, revision, question paper solving. So do subscribe and let's get started. Friends, so let's get started with our specimen paper solving. So here we have a section A and question number 1 on your screen. An aqueous solution of copper sulfate turns colorless on electrolysis. Which of the following could be the electrodes? So they gave us three systems in which anode, in the P we are having anode as a copper and cathode is copper again, and Q in which platinum is used as an anode and copper is used as a cathode. And one more, in Q we are having copper as an anode and platinum as cathode. So here we have four options. Only P, only Q, only R, both Q and R. So you should think in such a way, like you should know what's the color of copper sulfate. We know the copper sulfate in aqueous form is blue in color, right? So it is blue in color. So blue color turns colorless. When it is going to convert into colorless? During this electrolysis. So who is responsible for that? Obviously electrodes are responsible. So which type of electrodes should be present over there? So if both anode and cathode is copper, then it is not possible. Obviously it is not possible. So this is wrong answer. Only P cannot be. Q, yes, it can be, because here we have platinum and copper. And it's a theoretical question. Obviously anode is used as a copper and copper is used as a cathode. So option Q is the correct answer. So here if we go into the options, we look into the answers, we will be having Q as a answer. So option B is a correct answer over here, option B. Now a compound P is heated in a test tube with a sodium hydroxide solution. A red litmus paper held at the mouth of test tube turns blue. Which of the following could compound P be? So they gave us an option over here. We have sulfates, zinc sulfate, copper sulfate, ferrous sulfate and ammonium sulfate. So obviously all are sulfates, right? So when any of this sulfate, when we are heating in a test tube along with hydroxide, so what does it mean? We are having a compound P, that is any sulfates. We don't know which is this sulfate, so let us write it as X. With that I am heating NaOH. So we know that whenever we react sulfates with hydroxides, it converts into hydroxide, right? XOH. So one more thing, what they are saying, when hydroxide, we got hydroxide over here, and when we dip or when we bring a red litmus paper towards it, it is converting into blue. It means we are having a solution which is basic in nature. So which is the basic here? Zinc sulfate, copper sulfate, ferrous sulfate or ammonium sulfate? We know that ammonium hydroxide is the weaker base, right? So what is this? This is the weakest base. So obviously ammonium sulfate is going to be a compound P. So option D is a correct answer. So option D is the correct answer over here. Next question, which of the following would weigh the least? Here we have 2 gram atom of oxygen, 1 mole of sodium, 22.4 liters of carbon dioxide, and 6.023 into 10 to the power 23 atoms of carbon. So we are going to convert all of this into its gram form. So 1 gram atom of oxygen, we must know 1 gram atom means how much. 1 gram atom of oxygen is equal to 16 to the 32 gram, right? And if we are talking about 2 gram atoms of oxygen, then it's going to be 32 into 2 into 32 again. And next, 1 mole of sodium. 1 mole of sodium means how much? 1 mole of sodium means obviously 1 mole is equal to its atomic mass we are talking. So it's 23 gram. Then 22.4 liters of carbon dioxide. So 22.4 liter means 1 mole of CO2. What is 1 mole of CO2? We are going to add its atomic masses. So carbon 12 plus 2 into 16. So how much it is? 16 to the 32, 32 plus 2, 44 gram. And this one is equal to 1 mole, and it means of carbon means 1 mole of carbon. So carbon is 12. So obviously 12 gram. So which is least here? Just look at its gram. Obviously option D is going to be answer because 12 gram is least over here, right? So option D is a correct answer. Next question. The equation below shows the reaction between X and dilute sulfuric acid, and they shown us some reaction. X plus H2SO4 gives me XHSO4 and H2. Which particles are responsible for conducting electricity in dilute sulfuric acid and compound XSO4? So when we are talking about a compound and its conductivity, the two electrical conductivity, obviously all the ions are responsible. Cation and anion, it means positive and negative. Both ions are responsible for conducting electricity. So here if I look into its option, we are having both positive and negative ions. So option D is going to be our correct answer. Option D is the correct answer over here. Let us move on to our next question. Assertion and reasoning type. Dry HCl gas is collected by upward displacement of air, and the reason here is HCl gas is lighter than air. So whenever this type of questions are asked, first just go through is you are going to check that is that particular statement is correct or not, true or false. So assertion says dry HCl gas is collected by upward displacement of air. So yes, true. It is generally collected by this method only. Which is this method? Upward displacement of air. Why? So the reason is given as HCl gas is lighter than air. So actually it is not lighter. HCl is denser than air. Denser means it is heavier than compared to air. So if it is heavier, so it is used over it. So this statement is true, but this is not true. It's a false. So both A, they gave some options over here. Just go through it. Option A are true and R is the correct explanation of A. Is that correct? No. Option B, both A and R are true, but R is not correct explanation of A. So yes, both A and R are A is true, but R is going to be false, right? So A is true and R is false. So option C is the correct answer. Next question is, structures of 4 hydrocarbons are shown below. How many isomers of butene are there? So to attend this particular question, you should know what is isomer. Isomer means what? They are having same structure but different. They are having same molecular formula but different structure. So most of the students are going to confuse here and they may mark 3 here, because yes, first is not going to be isomer because here we can't see any type of double bond, so it is not isomer. But here 1, 2, 3, 4 carbons are there and double bond is there, so butene, yes. 1, 2, 3, 4 butene, yes. 1, 2, 3, 4 butene, yes. So they are going to answer as 3, which is not a correct answer. Why? Just look into its structure. So here if you number for first carbon, second carbon, third carbon, right? So to the second carbon double bond is there. Here 1, 2, 3 and 4. Again 4, and to the first carbon double bond is there. And here 1, 2, 3. To this first carbon again double bond is there. So can you see this structure and this structure is exactly same, right? Because to the second carbon you can see double bond here, and even here if you see, if you start numbering from this side 1, 2 and 3, to the second carbon double bond is there, right? So this structure and this structure is exactly same. So you can't say these two are different isomers. So when the structures are same, we can't say that, right? So here we can see only 2 isomers of butene. So the correct answer over here is 2. So 2 is the correct answer. Element P has electronic configuration of 2, 8, 8, 1. The number of chlorine atoms present in the chloride of P is. So they gave one element and its electronic configuration is also given, that is 2, 8, 8, 1. The number of chlorine atom present in the chloride of P. So when P reacts with chlorine, obviously we are going to get chloride. So this P is not phosphorus, any element it is going to be. They are not talking about a phosphorus only. It is they are saying any element whose electronic configuration is this. So whenever element is having electronic configuration like this, it means this particular element has the ability to lose this one electron easily. So can I say this belongs to alkali metal? Because in the periodic table all the alkali metal has a tendency to lose one electron. So when it is losing one electron, obviously it's going to form a bond with a element which is having, and look at the chlorine. If you see the electronic configuration of chlorine, it is 2, 8, 7, right? So it has tendency to accept one more electron so that it acquires octet configuration, right? So how many, obviously when it has a tendency to accept only one electron, how many bonds is going to form? Only one single bond. So this P has the ability to lose one electron and chlorine has the ability to gain one electron. So obviously the bond formed between P and Cl is going to be only one, right? So how many chlorides are present in this chloride particular, how many chlorine atoms are there? Then we can say it is only one single chlorine present in the chloride. So option B is the correct answer. Option B. Option B is the correct answer. Next question. H1H2 is the isotope of hydrogen in modern periodic table. It will be option A, be placed before hydrogen. After hydrogen, it is placed at same position as hydrogen, and not have any position in the periodic table. So this question is, whenever we talk about isotopes, yes, we came across isotopes many times, and we know that in periodic table there is no separate place for isotopes. If I talk about hydrogen, carbon, even carbon has different isotopes, like carbon 12, carbon 13, carbon 14, right? So it doesn't mean that we are giving a separate place for all this carbon. They are having same place because we are arranging elements according to its atomic number, not according to its atomic mass number. So isotope of hydrogen, even this isotope is having same atomic number, that is 1. So it is going to be placed at the same position as hydrogen. So option C is the correct answer. Option C. Option C is the correct answer. Next. A nitrate which forms precipitate with ammonium hydroxide and is also soluble in excess of it. So they are talking about a nitrate which forms precipitate with ammonium hydroxide. So it's again an understanding part, a theoretical part. We came across these nitrates. So when any of these nitrates, if I talk about ferrous nitrate, ferric nitrate, lead nitrate, copper nitrate, when we are reacting this nitrate, they generally forms precipitate when they react with ammonium hydroxide. So which particular nitrate is soluble in excess of ammonium hydroxide? So we know that generally copper nitrate is soluble in ammonium hydroxide. So option D is the correct answer over here. Option D is the correct answer. Option D is the correct answer. Next. Which of the following electronic configuration represents the most electropositive element? Most electropositive. So we know that what is the meaning of electropositive? When an element has a tendency to lose electron. When an element has a tendency to lose electron and become positive, we call it as electropositive. And alkali metals are generally electropositive elements, right? If I compare alkali and alkali earth metal, who are more electropositive? Obviously alkali metals. So by looking into its option, we can just remove two options, that is C and D. We can easily remove. Option D is also wrong. Option C is also be removed. We are left with option A and D. So both are having one electron in its valence shell. So who is going to be most electropositive? When I compare these two, obviously option B is going to be answer because they have more tendency to lose electron compared to option B, because once it loses its electron, it is having 8 electrons in its inner orbital, which is more stable. But here they are forming a duplet configuration, which is, yes, again it is stable but not as octet, right? So option B is the correct answer over here. Alkali metals do not form dipositive. Assertion is alkali metals do not form dipositive ion. And the reason, atom loses one electron, alkali metals achieve stable electronic configuration of noble gas. So here the option, again whenever they ask assertion reasoning type of question, you are going to see is that particular statement is true or not. If both are true, then we are going to move. Is that a correct explanation? Is the reason is properly explained for this statement, that is assertion. So alkali metals do not form dipositive ion. Is that true? Yes. They do not form dipositive ion. Alkali metals are forming only one positive ion. They won't give out 2 electrons so that it converts into dipositive ion. So assertion is right. Assertion is right. But when we come to reason, After loss of one electron, alkali metal achieves stable electronic configuration of noble gas. Yes, this is also true. After losing one electron, alkali metals achieves their stable form, right? So it is also correct. Now, is this reason is a proper explanation for this? After loss of one electron, alkali metals achieve stable configuration. So that's the reason why it is not going to be a dipositive ion. Yes, true. So reason is a correct explanation for this statement given. So which is the correct option here? So option A, both A and R are true, and R is the correct explanation of A. So option A is going to be a correct answer here. A ratio between volumes occupied by 4.4 gram of carbon dioxide and 2 gram of hydrogen gas is. So they gave us a ratio of carbon dioxide and hydrogen gas. Ratio between carbon dioxide and hydrogen gas. So before we write on the given part, let us write down its gram, means its molecular mass. So what is the molecular mass of CO2 here? Obviously, when you calculate, when you sum up its atomic mass, you are going to get 44 gram. And what is the atomic mass or molecular mass of this hydrogen? It is 2 gram, right? So here we have 44 gram is to 2 gram ratio, right? Okay. Now let us take the given part. Given is 4.4 gram is to 2 gram. So just look at the ratio. Here the ratio is in, if I convert this into the smallest ratio, how I am going to do this? Divide by 2 both the sides. It converts into 22 is to 1. Here if I divide by 2 both the side, it is going to be 2.2 is to 1, right? So again I can change this into, how can I change this? They are asking us the ratio in their volumes. So what is the best way to change this? We are going to convert this into mole. Yes, we are going to convert this into mole. So here this is 1 mole, this 2 gram is 1 mole, but what about this? This is not 1 mole, this is 0.1 mole, right? So 0.1 mole is to 1 mole. Can I convert this ratio into 1 divided by 10? Just by multiplying 10 on both the sides. Yes. So the option C is the correct answer over here. Aqueous lead 2 nitrate can be distinguished from aqueous zinc nitrate by adding any of the following solution in excess except aqueous potassium chloride, aqueous sodium sulfate, dilute sulfuric acid, sodium hydroxide solution. So aqueous lead nitrate, how can we distinguish with zinc nitrate? We are differentiating between lead nitrate and zinc nitrate, and which is the proper solution which is going to distinguish between these two things. So obviously here sodium hydroxide is the correct answer. Option D is going to be a correct answer over here. Option D. Sodium hydroxide is the one which can distinguish zinc nitrate and lead nitrate. The question is how zinc nitrate, when reacts with when it reacts with sodium hydroxide, it gives us zinc hydroxide, which is soluble in ammonium hydroxide. But in a similar manner, if I react lead nitrate with sodium hydroxide, it gives us lead hydroxide, which is not soluble in ammonium hydroxide. So again, sodium hydroxide is used to distinguish between these two chemical compounds. Here we have our next question. Which of the following about oxide is correct? Which of the following is about oxide is correct? So option A is basic oxide is an oxide of non-metal. Basic oxide is an oxide of non-metal. Is that correct? So before we know that, let me write down its basic oxide and acetic oxide. So before we move on, we should let us write down one example for basic oxide. When we talk about basic oxide, obviously it's going to be any of sodium oxide or potassium hydroxide or magnesium oxide, right? So what is this? These are the metals, right? They are metal oxides, right? So can I say metal oxide is the oxide of metal? So is the first option is saying correct statement or not? Yes, it is obviously not. It is wrong. This basic oxide is oxide of non-metal they have given, but the correct one is metal. So it is not correct. Acetic oxide contain ionic bond. Do acetic oxide contain ionic bond? Let me write down the example of acetic oxide. CO2 or SO2. These are the oxides of acid, right? And carbon and sulfur is, carbon dioxide is not having ionic bond, it is obviously having a covalent bond. So I can say acetic oxides are covalent in nature and basics are ionic. So this is also wrong. Option B. Amphoteric oxide contain metal. Yes, generally amphoteric oxides are always having metals, they are not having non-metals. So option C is the correct answer over here. They have asked which is correct. So option C is the correct answer. Now let us move on. The last question. A student takes copper, aluminum, iron and zinc strips, separates in a 4 test tube labeled as 1, 2, 3, 4 respectively. He adds 10 ml of freshly prepared ferrous sulfate in each test tube and observe the color of metal residue in each. So what they have done? They have taken 3 test tubes and they have added different metals like copper, aluminum, iron and zinc, and they observe the change in it. So when they have added these metals along with FAS, like ferrous sulfate solution, which is going to change its color, which is going to give us a black residue. So that is test tube 1 or 2, 1 and 3, 2 and 3 or 2 and 4. So these are the options they have given. So we must know its reaction. So when copper reacts with ferrous sulfate, first you should know, is this copper reacts with ferrous sulfate or not? To know this, you should remember metal reactivity series, that is potassium, sodium, calcium, magnesium, aluminum, zinc, iron, titanium and all, right? So here if you look into its reactivity series, you are going to see copper is below iron. Copper is below iron, so it cannot has capacity. It is less reactive compared to iron, so it won't react with iron sulfate and converts into copper sulfate. So no reaction is observed in this particular case. But what about aluminum? But when aluminum reacts with FeSO4, it gives us AlSO4. So this is black in color again. So aluminum sulfate is a black residue. So option test tube 2 is going to be our answer. And again one more. Iron won't react with iron to give iron sulfate, and zinc When it reacts with sulfate, it converts into zinc sulfate. So zinc sulfate is again black in color, which gives us a black residue. So test tube 2 and 4. Test tube 2 and 4 is going to be answer. So option D. Option D is the correct answer. So I hope you have understood this video, you have learned something, and further question 2 and complete solving. For part 2, go check out more videos of